Now we're going to work through an example, finding the tangent of our equation when x is equal to 2. Our equation for the tangent, so that you remember, is that our y is equal to the derivative at a point outside of x minus that point plus the function value at that point. Our first step will be finding our function value at our x value. So we're going to solve when g of 2 is equal to 1 over 3, 2 cubed minus 2 times 2 plus 2. Our 2 cubed, well, 2 times 2 is 4, 4 times 2 is 8, so it's going to be 8 on 3. 2 times 2 is going to be equal to 4, plus 2 at the end. This part here, well, 2... Now we're just going to solve the equation. So we've got 2 cubed, which is going to be 8, so that's going to be 8 on 3, minus 2 times 2 is going to be 4, plus 2. Now, this end part here, well, minus 4 plus 2 is going to be equal to minus 2. Now, because we've got our first part here as a fraction, we need to turn our remainder here into a fraction as well. And the way we do that is by timesing it by 3, which is going to give us minus 6, but it's going to be the same as minus 6 on 3. And that gives us our result, which is going to be 8 on 3 minus 6 on 3. Now, 8 minus 6 is 2, so it's just going to be equal to 2 on 3. Now we need to find the derivative. So, what's our differentiation rule? Well, when we have a function of the form k to the x to the n, where k and n are numbers, we can find the derivative of just bringing the n down to the front, which gives us kn, and we have n minus 1 to the power. Now to find the derivative, I'm just going to make us some more space. So moving this over here. So finding the derivative, we're looking for the g prime of x. We're going to be using our differentiation rule. So our k in our first point here is going to be the 1 over 3. The n coming down is going to be 3, so it's going to be 1 over 3 times 3, which is just going to be equal to 1. So we're going to get x to the 3 minus 1, which is equal to 2. Then we're going to have minus 2 times the 1 comes down, so it's going to be 2. And the x to the 1 minus 1 is going to be equal to x to the 0, which is just equal to 1. And there's no x with our plus 2 here, so we don't need to differentiate that at all. Next, we just need to solve our derivative when it is equal to our x value. So we're looking for when g prime of x is equal to 2. So we just put 2 into our equation, so that's 2 squared minus 2, which is just going to equal 2. As 2 squared is equal to 4, 4 minus 2 is equal to 2. Now we have all the information that we need to start looking at our equation for a tangent. So our equation for the tangent, y equals, in this case is going to be g prime of 2 outside of x minus 2 plus our g of 2. We found out that our derivative at 2 is equal to 2, so we put that in. And then we put in x minus 2 plus our value of g at 2, which was 2 over 3. Now we just need to expand the brackets and simplify. So we'll end up with 2x minus 4 plus 2 on 3. Now simplifying this part here, we're going to times the 4 times 3 is going to give us 12. And we're going to divide that by 3, which is going to make it the same as 4. Now we can put this into our equation, which is going to give us 2x minus 12 on 3 plus 2 on 3. Minus 12 plus 2 is going to give us minus 10. So it's going to be equal to 2x minus 10 on 3. So that is our equation of the tangent when x is equal to 2. Now let's have a look at what that tangent looks like. So our orange line here is going to be our original equation, and our purple line here is our equation of our tangent. So our y is equal to 2x minus 10 on 3.